Let us now talk about different types of features provided in modern operating systems. We shall also be discussing different concepts associated with operating systems. Although the title says types of operating system, it is in the same operating system you could have multiple features. The first type of operating system is a single user operating system. For example, when you're using a laptop or a desktop, you have an operating system which permits only a single user to use the operating system at a given amount of time or at a given point of time. So all the resources are dedicated to a single user and he or she has complete control over all the resources. Examples of single user operating systems are MS-DOS, Windows 95 and 98, Apple Macintosh operating system, and so on. So on your PC and desktop, if you're using one person at a time, it is invariably going to be a single user operating system. MS-DOS stands for Microsoft Disk Operating System. This was the operating system where it was quite popular about 25-30 years back, and where we started doing our engineering or started learning developing applications on that. Now let's try to understand what is batch operating system. Let us say I have to process salary of all my employees. I have to also generate the credit card statements. I also need to generate the PF account details and multiple other jobs. So if you look at the jobs mentioned by me, there is data already available. There is only calculations to be done and the results are got to be printed out. Now, this is an example of application which is heavy on calculations or computation resources, but there is almost little to no input being provided by the user. I am not entering the data for each person one at a time. The data is already there on the hard disk. The data is going to be read by my program. It's going to be processed and the result going to be come out on the printer or on the file as a hard disk. So in batch operating system, what an operator does is he or she will provide the jobs or the programs. He will provide the associated data in files and he will provide the instructions using a job control language as to how to process the job. So the jobs are grouped or sequenced one after the other. That means I first want my salary to be generated. Next, I want all the loan information of my employees to be printed, followed by what is my inventory stock that to be printed, and so on. So all these are grouped together and they are executed one after the other. Okay, they are grouped in a batch. They are sent as a batch of work, but the batch consists of 3 or 4 different types of works, or it can be any number of works. So here if you see, these are computationally heavy with very little or no input or interaction with the user. Now the principle the operating system works here is known as FIFO, or first in first out. Whatever order I submit my work, the first submitted will get executed first, the second submitted will get executed second, third in queue will get executed third. IBM 360 was a machine which used OS 360, and that operating system has a facility for batch operating system. Big companies still today use batch operating system for processing a number of things where there is no user interaction or user is not required to enter data or interact with the PC. For example, let's say think of a bank. Let's take HDFC Bank. In that bank, let us say I have to generate my savings account statement, followed by current account statement, followed by the salary of the employees, followed by the credit card bills. So I will put all of these programs along with their data. I'll submit it to this computer which works on the batch operating system. So it will do the jobs in the queue I submitted. That is known as first in, first out. Now, the reason this batch operating system is useful is the CPU is utilized at all point of time, and it is used in cases where you want to ensure that all the hardware resources are efficiently used. As one job is continuously using the CPU, okay, the other jobs are waiting in queue, and as the job is processed, the next job is submitted. But the drawbacks of this is It doesn't provide for interactivity. That means if you want to enter data online, it's not a good approach. And if there is a mistake, you have to stop the program, correct the errors, and resubmit and do the debugging. So this is used for heavy hitting jobs like in banks and things like that. Now let's understand the next terminology referred to as multi-programming, or an operating system which supports multi-programming. Let us think of a computer which has only a single CPU or a single processor. The facility or the feature of this operating system which permits the execution of more than one program at the same time or in parallel or concurrently is known as multi-programming. Now let me give you a simple example. Let us say I'm playing a video game. At the same time, okay, in that computer, I'm also trying to check if vaccination slots are available in CoWIN every 2 minutes. And let me say instead of CoWIN, let me say I'm playing two games in parallel. Okay, I'm playing two games in parallel. So what the CPU does is when you're with one game, it will dedicate all its resources to you. When you switch over to the other game, all the resources, whether it's IO, screen, printer, everything, keyboard is dedicated to you. So the CPU switches from one program to the other very fast, giving you the feeling that one processor is supporting the work of both of them in parallel. It gives you the feeling that the CPU is allowing you to do two things in parallel, whereas actually it has stopped attending one thing and started attending the other part. But since it switches or moves between the programs so fast, you hardly feel any difference and you feel you're getting a parallel service from a single processor. Now let's take a look at what is multitasking operating system. Now, the user could be browsing the web, could be working on a Word document, could be working on an Excel document, listening to background and music, watching a video parallelly, checking his email, and so on. So all these are example of different tasks. An operating system which allows all these processes to run concurrently at the same time is referred to as a multitasking operating system. Generally, a single CPU or a resource is shared between multiple applications or tasks. These are all different tasks I am doing, but the same CPU or the same printer or the same monitor or the same keyboard is used across all the tasks. Let me give you a better example or a more practical example. Let us say 50 students are connected to one powerful computer and they are learning C++. You don't require to load 50 copies of the C compiler. You will have one copy of the C++ compiler. All the 50 different programs will be there. So those 50 programs will use the same compiler to get their programs compiled. Thereby code and data, memory, resources are going to be shared between those different programs and processes. Now, since it's just a single CPU most of the time, suppose it is executing my program or it is working on my program. It gives a small millionth of a second to my program, then it shifts to your program. Since the switching is so fast, you feel as though it is attending it to you exclusively. Now, sometimes what is happening is, say it has to switch from my program to your program, and then it has to come back and restart the execution of the program from the point it stopped. That is known as the context. Suppose, think of it like this. I have read the matrix. Okay. After reading the matrix, I am going to do the addition of the matrix. So assume that the CPU has given me time to read the data into two matrices and then it decides to switch. It goes to a different program of some other user. When it comes back here, it should execute from addition of the matrix, not restart processing from the beginning. So whenever it is going to a different task like a web player or a music or a browser, it comes back to the old task and continues to execute it from the point where it halted or stopped. This is known as saving the context, and moving from one program to other is known as context switching. Because one context is I'm browsing the web. Next context is I'm playing the music. Third context is I'm viewing the email. Fourth context is I may be watching a movie. So for all of this, it notes down where I am and it exactly goes back at that point to continue to allow you to do what work you're trying to do. Now, most of the modern operating systems provide you this multitasking this thing, but still examples are Windows 2000, IBM 360, and Unix and Linux are examples of multitasking operating system.